like from the ceiling. It's really hard to graph on a whiteboard. Tomorrow we're going to be writing equations for graphs, so like I need to have the picture of the graph already up there so that we can write equations for it.
You can't exactly go in there.
No, not beforehand. No, I can't. So,
Does he have a class before?
well, I have a class. So,
Oh, yeah, study.
yeah. I think he might do. You know. So we'll see. I'm trying to find a room that I can go to 7th period, but pretty much. Yeah, right. Yeah, just be like, okay. I can't even like use an iPad and display it because there's nothing to display it. Do you remember the old projectors? Yes, that was like a little fan. It was a box.
It was like
The
big
teacher
brown
always let you
box.
walk up there and write on it.
Yes. Yeah, and then you just erase and you start over. Like I want one of those. That's all I want. I don't need anything else. That little old school projector.
You don't need any of this space.
No,
But you might record that.
that's true, right?
You could set your iPad up.
You could
Right,
set
no,
the
I
camera.
could just. Yeah, we can still get it to work. I'm sure. Okay, so there we go. Just kind of talking about those 4 letters that we looked at yesterday. Those 4 letters still mean the same exact thing. The A value is a 4th. What's the amplitude? There is none. So on the quiz next week, Tuesday, when I ask for the amplitude, you better say none. But I still will have people that tell me it's 1/4. But there is no amplitude. With the secant, the cosecant, the tangent, the cotangent, they all go up to infinity or down to infinity. So there is no amplitude. The amplitude is the highest part of the graph. And only sine and cosine have a max and a min that actually stops instead of just going on forever. So yes, the A value is 1/4, and that's part of the graph, but the amplitude is none. The B is the number in front of x, and that's just 1. Brandon, what is the period usually for cotangent and tangent? Pi. So you're still taking pi divided by b, but pi divided by 1 is just pi. So tangent and cotangent have half the distance. C, what's the C value up here, Michael?
Negative pi over 2.
Oh, so close.
Or just pi over 2.
Just pi over 2, because this graph is really shifting to the right. So our phase shift is still C over B, but C over B is pi over 2. Because pi over 2 divided by 1 is still pi over 2. And then the D value, if there was one, it would have like a +1, a +2, a +3, a +4. That D value would be sitting back here. So there is not one. All right, so that would be the information about the graph. To actually get the graph, that's where we're going to find some asymptotes. And we're using the fact that this is cotangent. You're taking whatever's after the cotangent. In this case, there's parentheses, so you're taking that x minus pi over 2. And setting it equal to where the typical asymptotes are for a general cotangent graph. So Virginia, one of the asymptotes would be located if it's cotangent. So just yes, there would just tell me what the typical asymptote would be. A 0. So a typical asymptote is at 0. Virginia, another asymptote for cotangent would be pi. And then a third asymptote for cotangent is negative pi. So these 3 numbers represent where the asymptotes are usually located if you just had y equals cotangent of x. We're going to find the new location just by getting x by itself. So that's, I think, what Virginia was giving me. So if you solve for x, taking pi over 2 to the other side, now I have an asymptote of pi over 2 instead of at 0. We also have an asymptote at 3 pi over 2 because you're adding pi over 2 to get x by itself. And then we have an asymptote at negative pi over 2. So that's the new location of your asymptotes. And that's just by taking whatever's after cotangent. So if there's parentheses, you're using whatever's in parentheses. If there's not parentheses, then it's whatever's connected with x, because x is what shifts the graph left or right. X is where the asymptotes move left or right. Questions? So that's all you need to graph, because the rest of it we're just going to do visually. So looking at the graph, pi over 2, 3 pi over 2, negative pi over 2, so that's where the asymptotes would be located. I'm going to count over 2 boxes and call that pi over 2. It gives us then a little more space. And then my next point, if I'm graphing or counting by pi over 2, this would be pi. And then here's another one at 3 pi over 2. Going the other way, over 2 boxes is negative pi over 2. I could go over 2 more and call that negative 3 pi over 2. So the graph is labeled. We just need to use those asymptotes and plot them as vertical asymptotes, those vertical dashed lines. Now we have some asymptotes for our graph. So the asymptotes are found by setting the equation after tangent or cotangent equal to 0 for cotangent, pi, and negative pi. And then the other information, what else do we have up here, Brandon, that we can graph? Not really doing any work.
Our x-intercepts.
And they're always where?
Right in the middle of the asymptote.
Right. So without doing any work, directly in the center of the asymptotes are your x-intercepts. So we would have one at 0, 0. We'd have another one in pi.
Is there going to be an exception for that, or is there no exception?
Nope, no exception. Because on the unit circle, everything's divided into fourths. And your undefined values and your x-intercepts are always the same distance from each other. Undefined values, x-intercepts, always the same distance. And then the last thing, Virginia. Says the what? It can move up and down. So yeah, if there was like a +1 up here, then that x-intercept would just move up to that location where like the new x-axis is located. That's that sinusoidal axis. So that they would just move up to that new location. But it's still going to be in the middle of the asymptotes. Other questions? So the last part we need to think about is the fact that it's cotangent. And there's a 1/4 in front there. So I'm going to go up 4 and down 4. Call that 1 and negative 1. Is cotangent an increasing graph or a decreasing graph? Chelsea? Decreasing. So that means now, like just like sine and cosine, everything is quartered. It's equal sections. So if you go to your intercept, in between the intercept and the asymptote on the left should be a point. That point is at 1/4. In between the intercept and the asymptote on the right is a point. That point is at negative 1/4. Because it's a decreasing graph, so it has to start higher on the left and it moves down on the right. And then just making them skim along your asymptotes, connecting those 2 points, would give you a tangent curve. You're going to repeat that for the second one. So in the middle of the asymptote and the intercept. Questions? So we're going to do 14 as well, and I'll talk a little bit about 15, or not 15, 35. So 14 said y equals 3 cotangent, so another cotangent graph of pi x. So we'll just look at that one. So A is 3, B is pi. So if we find the period by taking pi divided by b, the period is now 1. And is there a c or d value? No, no parentheses, so there can't be a c. D would be that number being added or subtracted at the very end, then there's not that number either. So the period is 1. How do you find your asymptotes for this problem? So what are we using to get an asymptote here? Lydia?
We're using pi, so it'd be pi x equals pi. And
Yeah.
then pi x equals negative pi, and then pi x
So pi x equals pi. Pi x equals negative pi. Pi x equals 0. So again, these are those three standard asymptotes. When it's cotangent, it's 0 and then multiples of pi. So pi to negative pi. So Libby, if you solve for x, you end up getting
1,
1,
negative 1,
negative 1,
and 0.
and 0. So our asymptotes are at 1, negative 1, and 0. I'm going to see if I can steal a graph from another problem. There it goes. Wow, really big graph. All right, so when we go to graph this, we don't have values of pi. That's all right, we can still graph. We're just not going to label it with values of pi. So we're counting instead, we have like numbers, 1, 2, 3, 4. But knowing that you have to have an x-intercept, I'm going to call this a half, and then we have a 1. On the other side, I'll make that a half. Here is a negative 1. So you can't, like, we need something in the middle of those two asymptotes. So if I just counted by going over and counting at 1, then I'm kind of not leaving a lot of space for that middle part of the asymptotes. So asymptote at a positive 1. Asymptote at 0. And then an asymptote at negative 1. So again, when you're counting, you have to remember that in between your asymptotes, you need an x-intercept. So that's why I just counted by 1/2, because somewhere in between 0 and 1, halfway in between would be 1/2, which would be where our intercept is located. So we'd have an intercept at negative 1/2 and positive 1/2. And this is cotangent, and it's a 3 in front. 3. So just like with the last one we did, so going to the x-intercept, cotangent is decreasing. So in between the asymptote and the x-intercept, I'm going to have a point up at 3. On the right side, I'm going to have a point down at negative 3. And then up at 3 and down at negative 3. That one looks a little better. First one wasn't as nice. So asymptotes intercept directly in the middle, and then your other 2 points are in the middle of the asymptote and the intercept. So you need 3 points. One x-intercept, the other 2 points should be a high and a low point to get that curve. Questions? So just quickly, number 35 gave you the fact that tangent was equal to 1. I'm trying to think what the exact directions were. It says use the graph of the function to approximate the solutions of the equation between negative 2 pi to positive 2 pi. So if you graph the regular tangent graph, which I'm going to steal instead of graphing it again. Right here. So here's our tangent graph that we graphed yesterday. Your goal is to find when the tangent is equal to 1. So we have a regular tangent graph. When it's equal to 1 would be these points right here. So your goal was to find those angles that would be associated when the tangent is equal to 1. So it's equal to 1 halfway in between 0 and pi over 2. So the tangent is equal to 1 at pi over 4. The tangent is equal to 1 halfway in between pi and 3 pi over 2, which would be 5 pi over 4. So that's what that question was asking you. So once you have a graph, finding out when is the tangent equal to 1, what angle goes pi over 4. The angle of 5 pi over 4. And this one would be negative 3 pi over 4. Those would be the angle values. Questions? So we're going to graph just one other problem today. And that is on that little sheet that I gave you because I was annoyed with the notes packet. So I kind of said forget it. So graphing secant and cosecant will be the other two remaining functions. In your book, there is a really great chart that organizes everything on page 310, and it shows you all of the functions, which is kind of nice to have. So it shows you the six functions and what those 6 functions look like. So the quiz on Tuesday, maybe in like a nice little diagram to look at. It gives you the range of the functions, the asymptotes of the functions, the amplitude, gives you a whole bunch of stuff about each one of the 6 trig functions. So cosecant and secant are graphed actually by using the sine and cosine. So if you can graph sine, then you can graph cosecant. If you can graph cosine, then you can graph the secant. So we have, for number 2, this is on the worksheet that you got when you came in, we have negative cosecant of 4x minus 1 in parentheses, and then plus 1. So we're going to pretend for a moment that this actually says sine. Because the sine and the cosecant are reciprocal functions. So if you have sine, the cosecant is pretty much going to do the opposite of it. So we're going to think right now that we're graphing a sine graph. And if you go back to graphing a sine graph, those same 4 letters, Chelsea, what would the A value be? Negative 1. The B is 4, and that helps us get the period, which for sine is 2 pi over 4, because it's 2 pi over B. So that's pi over 2. The C value, what's C in this problem? Chelsea? Pi, yeah, so C is pi. Even though there's a negative, it's really moving to the right by pi. So C is pi. That helps us find the phase shift, which is still C over B. So the phase shift is C over B. So that means the phase shift is pi over 4. That point is really important because that's where we start our graph. It should start at pi over 4. And then D is plus 1. That means at the end of the problem, all of my graph, or all the points of the graph, really are moving up 1. They're all shifted up 1. What else do we need to know to graph this? So we know it starts here. That's the first value it starts at. What else do we need? How do I find the next value? Michael?
The key point, is that what it's called, right?
Yeah. How do you get that key point?
You do the period divided by 4.
Nice. So he said period divided by 4. Well, since we have a fraction, we can multiply it by 4. So Michael, what would we count by?
You count by 2.5.
So if you're dividing by 4, you're really multiplying by 1/4. So what's pi over 2 times a 4?
Pi over 8.
Pi over 8. There we go. So that's what you're going to add to get to your next angle. So we have pi over 4. We're adding pi over 8, which makes 3 pi over 8, because pi over 4 is 2 pi over 8. And then I'd add pi over 8, so now I have 4 pi over 8, which is pi over 2. And then 5 pi over 8. And finally 6 pi over 8, which is 3 pi over 4. So again, this is graphing sine. I haven't done anything different yet. I just made it a sine graph. So then we have to think about the sine and the y values of the sine. Brandon, what are usually the y values of sine?
0, 1, 0, -1, 0.
What are you doing with those y values to find the new number?
You're multiplying by the amplitude, and then after that you add your d value.
Good. So you're multiplying by the amplitude, so you're taking the y value, multiplying by the amplitude, which is -1. And then he said add the d value last. So Brandon, if we have a 0, you're multiplying it by -1 and then adding 1.
It would be 1,
It would be a 1. And then the second value would be
0. Yeah. 1.
Mm-hmm.
That would be 2.
And then finally
1.
a 1. Thanks, Brandon. So you're first multiplying by the amplitude, and then you're adding 1. And that's what we did when we graphed it sine and cosine. So multiply by the amplitude and then add or subtract the d value. That's the last thing we look at. So now we have everything we need to try and graph this. And again, I'm not graphing cosecant yet. I'm still graphing sine. The least common denominator is pi over 8. So we have to count by pi over 8. If you want to go over 2 boxes and call that pi over 8, you can. Totally up to you if you want to make it spaced out a little bit more. So I'm going to just call this pi over 8. 2 more boxes is pi over 4. And again, I'm counting by pi over 8 because that's the least common denominator. So pi over 8, 2 pi over 8, this is 3 pi over 8. 4 pi over 8, which is pi over 2. 5 pi over 8. And then 6 pi over 8, or 3 pi over 4. So I just went over 2 boxes to give it a little more space, counting by pi over 8 each time. And then getting my y-axis. So still graphing sine. We have the points. My first point is at pi over 4 and up at 1. The 3 pi over 8 is at 0. Pi over 2 is up at 1. 5 pi over 8 is up at 2. And then 3 pi over 4 is at 0. And if you want to lightly sketch yours in, or like dash it in, then I'm going to move in the other direction to get a second graph, because we need 2 periods. So it has to go up, down, all the way down, and then back up. So remember, when you're graphing sine, sine is a continual up, down, up, down, up, down, up, down. I started at pi over 4, I just then graphed backwards as well. I know, that's kind of confusing. So I did start at pi over 4. Right here is my first graph, and then I graphed the other way. I'm going to just dash in that line where my new sinusoidal axis is. So that's like the new x-axis shifted up above. That's at y equals 1. So the last thing we now need to do is actually graph the cosecant, which is really no work because you've done all the work. We need asymptotes. Because if I'm graphing the cosecant is 1 over the sine. So whenever sine was supposed to have a 0 value in x-intercept, it's now undefined because 1 over an x-intercept, 1 over 0 is undefined. So wherever it's on the sinusoidal axis is now going to be an undefined value because that's technically where the x-intercept is located. So at any sinusoidal axis point is now an asymptote. So sine and cosine are the only graphs that don't have asymptotes. They're the only graphs that are not undefined. Because the domain for sine and cosine is negative infinity to infinity. And the range has no undefined values as well. It just goes from -1 to +1. And then the last part, this is a reciprocal graph. So whatever the sign does, the cosecant does exactly the opposite. So if you go to any of your max or min values, so here's a min value, the cosecant is going to do the exact opposite, meaning it's going to open in the opposite way. So the cosecant goes down, or when it's a part up here at the top, it's going to go up. So it opens the opposite direction. So you have all these little parabolas, but they're bounded parabolas by those asymptotes. So somebody in the other class said, do we actually have to graph the sign? No, you don't have to graph the sign. You could just plot the points and not technically sketch in the sine curve, and then just graph knowing it's the opposite direction. So the cosecant graph would be the 4 parabola shapes, 2 pointing up and 2 pointing down, that are graphed from using the max and the min values of sine or cosine. So if you were graphing secant, you would graph cosine. Questions? So the homework is all graphs. Please graph every single one of them. I sprinkled in a couple of tangent and cotangent graphs in there. I think there's one of each, so they have 1 or 2 to graph. And then tomorrow we're going to write equations for graphs. So you're going to see the graph, see the picture. We're going to come up with the equation just like we did for sine and cosine. And did I do your problem?
No.
No. What problem did you have? You should have.
Still has time.
She still has time. Oh.